So if you remember, we had an issue with vibration on the motor on the Jeep. And so what we've done is, I mentioned the guy that normally did our dynamic balancing has left the radar. And so I'm going to do this myself, and I'm going to do it in a couple steps. One is going to do it what they call statically, and I'm just trying to get it as best I can with this inexpensive static balancing system here. Because of the friction, not going to be perfect, but we can do some fine-tuning at this point. And so this will be step one. And we've been able to see that there's a repeatability on this. And I've done it numerous times. I've added some weight already, opposite of the heavy side. And we're going to see what it takes to get this thing dialed in as best I can with the limitations of doing it this way. From here, we're going to go to a dynamic setup, which is going to be, again, it's going to be somewhat, I don't know if I want to use the words hit and miss, but it's going to take a lot of kind of trial and error to find that sweet spot. But I'm going to do it by mounting this assembly to a Warp 9 motor that I have and turning it with 12 volts, which will be about 3,000 RPMs, and do it until we get the smoothest ride. And so it will take some time to dial that in, but it's so far out now I wouldn't dare spin it up to 3,000 RPMs now. It'd vibrate everything, the workbench would vibrate away. So we're going to take out the worst of it using the static method, and then we'll see what we can do with the with spinning it. And there's a program that you can get online that and there's other people that explain it, so I won't bother going through all of it, but basically you're going to take 3 evenly spaced points, so that's 120 degrees increments, and you're going to add and subtract weight, and you're going to record the amount of and so this is somewhat subjective. If you use some kind of instrumentation to measure the vibration or flux, it's going to be mounted on a motor, so I'm not going to have any fluctuations. So I'm going to do it strictly off of vibration. And so like I said, it'll be somewhat subjective. As I move the weights around, I'm going to rate it, that this is, a certain rating that I'll put into this program, and that it, mathematically will dial it in, tell me where to put, the weight next. And so through that repetitive process, we're going to dial this in as best we can. And so we'll show you that. I'll show you when we, once I finish doing this, we'll show you what the first spin up looks like after we balance it this way, and then I won't bother, showing you all the process in between, but then I'll show you the after. So we'll, you could probably hear the before in the Jeep, and we'll do the after in the Jeep also. But something needed to be done. It was way out of balance. You can see even after I added weight, this thing, it's definitely got a heavy spot in it. So that's what I'm doing now. I'm doing it kind of, I don't want to say an unorthodox way, but it's definitely not the way that we have done it in the past, where we went to a guy that had specialized equipment, and he balanced all sorts of things. I mean, he had multiple high-dollar, high-tech machines that were designed to balance different types of motors and flywheels, so forth. Okay, now for the spin test. We're going to do it in a couple different steps. One, we're going to spin up the motor just by itself. Then we'll put the coupler on, spin it up. Put the flywheel on, spin it up. Put the pressure plate on, spin it up. And we're going to see, what the vibration level is at each step. Now, what I've got set up here is we have a battery backup set up here, and it consists of 4 of the Battleborn 100 amp hour cells. We've got a solar charge controller. We've got a 3,000 watt inverter charger combination, and so we can recharge these Battleborns by either plugging into the grid or solar. So that's going to be our power source, is 12 volts. And you see one on the workbench, there's 3 down below. So I have 400 amp hours at 12 volts. And that then is coming, positive side comes here to a contactor, goes through the contactor to our motor. And the motor is a series wound DC motor, and so this is coming to the armature and goes through the brushes, commutator, through the armature, comes back out of the armature right here, it's jumpered here to the stator, goes through the stator, comes out here and goes to our negative of the battery. So simple series circuit, and we have the contactor in there just so that we can switch this on and off conveniently. So what we'll do first is we'll run this up with nothing attached to the motor, just the motor. And you might notice that we don't have the screen on the back side of the motor here. This is one that we use in our workshops just as a demonstration display of a DC motor, series wound DC motor. And so without the screen cover on, I could have put it on for this purpose, but not going to be sitting here that long, and it'll be back on the engine stand where it normally sits. But anyway, we're going to run it up without anything. Here we go. And you can see the current draw. It's dropping. When I first hit the switch, it hit about 75 amps. And we have stuff sitting on the workbench. And all of that sitting nice and smooth. So the motor by itself is running very smooth and nice. We've dropped down to 36 amps. So it runs nice and smooth. So next, I'll heat up and install the coupler, and then we'll run that up. And now we have the coupler attached, and let's spin it up and see what difference that makes, if any. it does make a little bit of a difference, but very little. So I mean, I can feel slight vibration now that I didn't feel before. But I'd say it's acceptable. So let's add the flywheel. Now, let's do the flywheel. So 114 amps to get the flywheel started. Continuing to drop current wise, and we're just slightly more vibration than we had before, so that flywheel feels pretty good. That's really not too bad. So it must be in that clutch plate. Let's attach it and see what happens. Okay, we got the clutch pressure plate attached. Let's see what happens. Wow. Color me impressed. The old static balancing did a pretty good job. Amazing. But this is the test. This is how you confirm that what you've done was, of value. We saw how it was in the car. I saw how far out it was on the static balancer, but running it, I'm guessing around 3,000 RPMs here, it's nice and smooth. Yeah, wow. I wasn't expecting that. That's running nice and smooth. Let's watch it roll down here. See if there's, an RPM where we get some vibration. Because there's different harmonic frequencies. Wow. That's a lot better than I thought. I thought because my static balancer wasn't, of the highest quality, those bearings weren't a style that has a lot of, or doesn't have a lot of, rolling resistance. And just the type and the style. It's made in China. But yeah, no. I was able to get it pretty good. It's not perfect, but I think it's definitely good enough. Yeah. Very impressed. Let me give you some more shots here. Nice and true. Stays just running really nice. What an improvement. Yeah, I'm happy. Okay, let's let her run down here. Well, now it's just getting it back in the vehicle. Yeah. There you go. It's amazing the resistance difference between the Series 1 DC and the AC. The ACs turn so much easier because they don't have that friction of the brushes. And so we've got 8 brushes around this thing. You can see it's a pretty good sized commutator. You know. So yep. All right, let's move forward.